Okay, guys, welcome back to Lesson 3. We're going into factoring today, your favorite from Algebra 1. So let's refresh on factoring quadratics. So always remember, always look for GCF first. GCF is greatest common factor. And when you are dealing with a GCF, what it will appear like in your answer after it's factored is your GCF will be outside of the parentheses, and then you divide to see what's left over inside the one set of parentheses. So let's do some GC to the F. So again, the directions are not going to tell you what exactly to do. They're just going to say factor. So as a reminder again, always look for GCF first. So you have two terms here. 2 and 4, what's the highest number that multiplies into each of them evenly without a remainder? Well, that would be 2. An x is common to both of them, so I will say my GCF is 2x. So, by the way, the x's in both of them were x squared and x. The one that you choose for a factor for a GCF is the smallest exponents. So then, what we have to do next is we got to see what's left inside that one set of parentheses. So we need to divide by our GCF. We're dividing by what we just took out. That's what factoring is. It's dividing into smaller parts. So 2x squared divided by 2x, it would be 1x. Remember, you subtract exponents. And then plus 4x divided by 2x, the x's cancel, and that would be 2. Letter B, the GCF of 10 and 35. What's the biggest number that goes into both of them? It would be 5. X is common to both of them, so x squared or x, you go with the smallest x. So there's your GCF. Now we need to divide by our GCF. So 10 divided by 5 is 2. X squared over x is x. And then minus, the x's are equal here. They cancel. 35 over 5 is 7. Next, the GCF of 18 and 6 would be 6. And the GCF would have an x in it, and it'll be x squared. We have x to the third and x to the second. Go with the smallest. So now we're going to divide by the GCF. To see what's left over in the one set of parentheses. So 18 over 6 is 3. X to the third over x to the second. We subtract to get x to the first. Then a minus. Now, here, it's dividing by itself. So that would be 1. The x squareds would cancel out. Anything divided by itself is 1. Just a 1 without an x. Next, letter D. What's the GCF of 21 and 7? That would be 7. Will it get a y? Yes, y to the second, the smallest one. 1 parentheses, divide by your GCF. That would be 3. 21 over 7 is 3. Y to the fourth over y to the second, subtract. And then here, it's the same exact thing dividing. Anything divided by itself is 1. 5 and 20 would make 5 for GCF. And then both have x's, so we're going to have x to the first for the smallest in the first term. And then divide by that. The first, it would be anything divided by itself. It'll be 1. And then minus 20 divided by 5 is 4. X squared divided by x is x. You pause this and try this one on your own. The GCF of 42 and 6 would be 6. 6 does go into 42 7 times. And does it have an x? Yep, both of them have an x. You choose the smallest, which would be x, smallest exponent. Divide by your GCF. The first term divides to have 7x. And then the second one is the exact same thing. Anything divided by itself is 1. All right, so that was factoring GCF. Please, YouTube, if you want to see more examples. Trinomials. Trinomial, we're going to have 3 terms now. Trinomials will factor into 2 sets of parentheses. And here's some trinomial sign rules. When we have, all of these are going to be in the form x squared plus bx plus c. When the b and c are both pluses, you're automatically going to have 2 parentheses that are x plus, and then we'll figure out what those numbers are. And by the way, to figure out what those numbers are, the rule we're going to be going with is the 2 numbers that we put, say, here and here, are going to have to multiply to get c and add up to get b. Other sign rules. The second one, when the c is a plus but the b is a minus, the signs are minus, minus, which makes sense because a negative times a negative would be a positive c. But when you add 2 negatives, that would be negative b. And then what the third one is saying is we look at c first. No matter what, if c is a minus, the signs in the parentheses are going to be plus, minus. Regardless, it doesn't matter if b is plus or minus. It's the c that you look at first. If the c is a minus, the signs are plus, minus in your parentheses. So let's take a look. So this is easy. We have all pluses. So we're going to go to 2 sets of parentheses. And our signs, very easy, according to the rules, plus, plus. So you need to think of 2 numbers that multiply to get 20 and add up to get 9. Well, you could if you can't think of it at the top of your head, what I tell people is write them down on the side, like the pairs that multiply to get 20. And I tell them to start with the number 1, like 1 times 20. That does not add up to 9. 2 times 10. That does not add up to 9. That adds up to 12. 3, 4, and 5. Well, those add up to 9. So that's my pair I want. 4 and 5. See, remember, this is dividing into smaller parts. And if you were to double check your work, you can FOIL your 2 parentheses and combine like terms. And if it turns back into your original problem, then that means you did it correctly. Moving on to B. Again, all pluses. That's nice and easy. The signs are plus, plus. I need two numbers that multiply to get 40. 1 times 40. Nope, that adds up to 41. 2 times 20. Nope, that adds up to 22. 3 doesn't go into 40. 4 goes in 10 times, and that adds up to 14. That's my pair. Done. Letter C, according to the notes, when the C is a plus and the B is a minus, your sign should be minus, minus. Now, you're still going to do the same rules of 2 numbers that multiply to get C and add up to get B. Ignore the signs right now. They're both the same, so it's really inconsequential. So what are pairs that times 30? Multiply to get 30. 1 times 30. Nope, we need it to add up to 11. They add up to 31. What about 2 times 15? Nope, they add up to 17. 3 goes in 10 times. That, however, adds up to 13. All right, 4, no. 5. 5 times 6. That adds up to 11. There's my factors. Okay, more practice. Plus, plus. So again, very easy here. What 2 numbers multiply to get 10, add up to get 7, 2, and 5. Okay, what are the signs here? Minus, minus. 2 numbers that multiply to get 36 and add up to get 15. So 1 and 36, no. 2 and 18, no. 3 and 12, yes. All right, letter F. The signs here, the C is a minus. This is our first problem where we have plus minus. these are the ones that are the hardest of the three scenarios. So we have to think here, what two numbers multiply to get C, but subtract to get B? 8. So 1 times 20. Nope, they don't subtract to get 8. What about 2 times 10? Well, yeah, they subtract to get 8. So that's going to be my pair. But I have a plus and a minus. So which one is it going to be? Well, which one makes, look at the sign of 8, the B. It's a plus. Which one would get a negative to make a plus 8? Well, that's easy. Negative 2. Negative 2 plus 10 is plus 8. So minus 2 and plus 10. And yes, it is very important. The plus must go in front of the 10. The minus must go in front of the 2. Okay, letter G, we have another plus minus because the C term is minus. I always do my signs before I worry about the numbers. So I need two numbers that multiply to get 40 and subtract to get negative 3 because I have different signs here. 1 and 40, nope, they subtract to get 39. 2 times 2 goes into 40 20 times. Nope, they subtract to get 18. We need 3. 3 doesn't go into 40. 4 multiplies into 40 10 times. Nope, that subtracts to get 6. Next after 4 comes 5. 5 and 8. Yes, there's our pair. They subtract to get negative 3. But what gets the plus? What gets the minus? So if you look at B, B is a minus. Where do you put, which number would you put a negative in front of to make them add up to negative 3 or subtracting a negative 3? That would be 8. 5 minus 8 is negative 3. So it's got to be a plus in front of the 5, the minus in front of the 8. Letter H, again, C term first. The C term's a minus, so we're going to have plus minus. So two numbers that multiply to get 20 and add up, or subtract to get 8. 1 times 20, now that subtracts to 19. 2 times 10, yep, they subtract to get 8. So which would, I need a minus in front of one of them, which would it be to make the B term true? Plus 8. Well, that would be minus 2, because minus 2 plus 10 is plus 8. So x minus 2 and x plus 10. Back to I. What do your signs have to be? Plus, plus. Everything's plus here. This is an easy one. What two numbers multiply to get 16 and add up to get 8? 4 and 4. Letter J, we got a back, again, C term first. It's a minus. What are the signs here? Plus, minus. I need two numbers that, since it's plus minus, multiply to get 63 and subtract to get 2. 1 times 63, do not subtract to get 2. 2 doesn't go into it. 3 goes into 63 21 times, but that subtracts to get 18. 4, 5, 6, 7. 7 goes into 63 9 times. That subtracts to get 2. There's my pair. But I need one with a plus, one with a minus, and it's got to make, look at the B term, a plus 2. So the minus would have to go with the 7 plus with the 9 to make a plus 2. Letter K, look at the C term first. It's a plus, but the B is a minus. So that would be, what signs? Minus, minus. I need two numbers that multiply to get 27 and add up to get 12. That would be pretty easy. 3 and 9. And then letter L, nice, easy, plus, plus here. Everything's plus. Two numbers that multiply to get 36, add up to get 15. 3 and 12. Okay, almost done. No, actually, we're not almost done. We are going to factor the quadratic completely. So we're going to mix up a little bit of what we've learned with everything. So what this means, hints at us, is Let's try to see if we have a GCF first. We do in A. 4, 20, and 56. 4 should be the GCF. So we have a GCF first of 4, not 4x, because 56 does not have an x. And then divide by the 4. 56 divides by 4 to get 14. Now, we can factor this further. It is a trinomial. So bring down the 4, go to 2 parentheses. What are my signs? C is a minus, so that means we got to have plus minus. And we need 2 numbers that multiply to 14 and add and subtract to get 5. 1 times 14, no. 2 times 7, yes. But one's got to get a plus, one's got to get a minus to make plus 5. The minus would have to go with the 2, because negative 2 plus 7 is plus 5. Let me erase that. That should be not a 5, but a 7. Okay, letter B. Does it have a GCF first? Yes, it does. It does have a GCF of 2. Just 2. So then that divides to have y squared plus 1y minus 40. If you want, if it helps, put in a 1 here. Now I can factor this further. This trinomial will make 2 binomials. What are the signs? Look at the C. The C is a minus, so it's got to be a plus minus. I need 2 numbers that times 40 and subtract to get 1. 140, no. 220, no. 3, 4, 10, no. 5, 8, no. Nope, hold on. I gotta rewind a bit. What did I screw up? I knew something wasn't making sense here. I forgot to divide the 40 divided by 2 to get 20. And I'm not gonna go back and start this video over from scratch. So we'll just have to deal with it. All right, 2 numbers that multiply to get 20 and subtract to get 1. That would be 4 and 5. Real easy in mental math. And then we need a plus and a minus. That would make a plus 1. So that would mean minus and plus to make a plus 1. Letter C, GCF. Yes, I got one here. It's a 4. Divide by 4. Let's see if I don't screw it up this time. Divide everything by 4. Make sure your T's are a little cursive so they don't look like pluses. All right, that trinomial can go 2 parentheses. What are my signs going to be? When the C's plus, B's minus, it's minus minus. And 2 numbers that multiply to get 12 and add up to 7, 3 and 4. All right, do I have a GCF in D? Yes, I do. 3. And then divide to have y squared plus 1y minus 12. I can factor that trinomial more. Bring down your GCF. Your signs, look at your C first. It's a minus, so that would be plus minus. So I need 2 numbers that multiply to get 12 and subtract to get 1. That's easy, 3 and 4. But what gets the plus, what gets the minus? We got to make a plus 1 here. So that would be negative 3 and plus 4. Okay, letter E, a little bit different here. Yeah, we have a GCF of 2, but not just 2, but actually negative 2. Whenever you start a problem off with a negative and you're factoring, you must factor out a negative. Whenever your first term has a negative, factor out a negative. So now we're dividing by negative 2. So change the signs. That should be plus 37x minus 6. Now, believe it or not, does that factor? No. There are no numbers that will multiply to get negative 6 and add up to 37. So that guy is actually done. The purpose of this problem was just to introduce the new rule of when your first term is a negative, factor out a negative GCF. So here, letter F, first term is a negative. So what's your GCF here? It's actually -1. So carefully divide by -1. It just changes the signs of everything. And then you're going to bring down your GCF. You don't need to bring it down as a -1. You just put a negative out in front. And this trinomial can be factored further. My signs here should be minus, minus. Two numbers that multiply to get 4 and add up to 5. Easy. 4 and 1. And then finally, we go into difference of squares, which is very easy. You can see examples below here. It's whenever you have something in the form x squared minus a number that is a perfect square. Remember, your perfect squares are these numbers. And then there's many more. Okay, they're the numbers when you take the square root of them, it gets a nice whole number. So they always factor into two parentheses with a plus and a minus. Now, I do want to illustrate that it is x squared minus a perfect square. It cannot be a plus. There's no such, it's called a difference of perfect squares because the word difference means minus. Okay, so this guy would be, you go two parentheses, just like it says above, always factor into x plus and x minus, and then what you do with that perfect square is, you just square root it. The square root of 25 is 5. So you put 5's in both of them. Letter B, they are perfect squares as well. So two parentheses with a plus minus. Now, 81g squared, you square root that to have 9g in both parentheses. And then the square root of 49 gets 7's. Letter C is a trick problem. At first glance, it doesn't appear to be a difference of squares. However, it brings in the rule that we had 5 minutes ago, which says that when you have your first term being a negative, you have to pull out a negative as part of a GCF. So we would technically say we have a GCF of -1 here. So now we divide by -1 to have g squared minus 100. What happened? It turned into a difference of squares. So now we can bring down the negative and we can go do our difference of squares. G plus, g minus, and then the square root of 100, we write 10s. So that's only 3 examples. Please feel free, if you want to see more examples, go on to YouTube and type in difference of perfect squares.